Okay, so I suppose following uh, Karthik Vaidyanathan, we are all awake because I was having a very collegey moment. Like when you come after lunch to your session, you're like, you want to sleep a little bit, but then I suppose everyone has woken you up enough so you can listen to what I have to say now then. Good. Thanks for that, more than anything. But there were quite a lot of things which you spoke about, which I could completely empathize with and agree with. And these are the calls we've been making, so I quite enjoyed your talk. Right. Cool. Um, right. So we are going to talk about the rise of adaptive agents. Apologies for the color, or whether if you enjoy it, I'll take the compliment because my co-founder, he went in Bahubali mode and he said, I don't want to talk about tech. I want to talk about, I want to tell a story. So let's tell a story is what he wanted to go with. So that's how we ended up with this thing. So it's going to be a cinematic experience is what he assured me because it's going to be a story. Okay. Now, again, as I said in the morning, it's such an honor to be here. Um, think about the last time when you tried to accomplish something like, approve a hire or fixing a billing issue or, close a customer ticket. You would have had to log on to 5 different systems and you had to chase like 3 different people and, you had to hand it over to a couple of people and then say, okay, this person will handle it and that person will handle it. Everyone will be logging onto a system, but then you have to go from one table to another table to get something done. Now, nothing here is hard because it is intellectually complex. None of the tasks what we are doing right now is intellectually complex. It's hard because the coordination part of it is kind of broken. Now, today I want to talk about a shift that's already underway, but not many people might have named it yet, and we are a part of that shift. Um, a shift that will quietly change how software works and how the work gets done and how humans will interact with machines. This talk is called The Rise of Adaptive Agents. Now, it's really about a story, how we move from apps to autonomous workflows. So, by autonomous workflows, we mean something which gets the work done rather than by itself, rather than waiting for a lot of things to be handed over and taken over and coordinated, where humans are at every step of the way. And this change is not going to happen tomorrow. It's not going to happen in distant future. That change is happening right now. Now let's start to talk about a paradox. AI has never been smarter than how smart it is right now. But still, um, why does work feel so hard? And we have models that can write code, pass exams, reason in natural language, and it can generate products. But why do organizations still struggle with delays and handoffs and manual coordinations and fragile automations? There's a contrast between the intelligence and the reality, and it's very, very evident. Now, the example is ChatGPT can write a perfect job description, but it takes hours and days to actually find the correct candidate, get them interviewed, get them scheduled for an interview, and then offer them a letter and all of that. So it takes a huge process. And finally, when you actually employ the person into the company, days have gone through, days in between have gone through. So, but in reality, what we would have liked to for it to happen is not saying, oh, here is the job description, and then here is um, someone saying that, okay, let's source all the candidates from a lot of other job sourcing sites, and then look at it, and then score how the resume looks, and then shortlist from there, and then see if we can schedule the top 5 candidates or 6 candidates for interview and calling them to do a phone screening with them, and then see if this guy is good or that guy is good, put them on hold and schedule an interview, and then with a real company, and then you're getting employed. So there's so much gap between when a job is come in the market and when you actually end up scheduling a person. Now we want to see if we can automate this. If we have an intelligent system, then that system would take it from when there's a job, get a candidate. That should be the intent. You're not going to tell the system, these are the steps you need to go through, And these are the check-off points you need to have to actually get a job, get a guy, placed. But you're going to want a system. You're going to say, when you see a job request, find the guy, find the guy and hire a guy. That's the intent you're going to tell to the system. Now, AI is basically everywhere, but the outcomes, which is a candidate who is hired, an eligible candidate who is vetted and hired, that kind of an outcome is not everywhere. Pilots do look very, very impressive, and then they kind of quietly die. Now, you can still see that the humans are running every step of the workflow. So the question is not, is AI intelligent enough? It's real is, why isn't this intelligence translating into action and translating into execution? The real problem is not that the intelligence is a bottleneck, but the execution is. AI can think and softwares can act. Think about this. AI can do the thinking bit and softwares can do the acting bit. Now, but they don't work together at the minute. We have built intelligence in one place, which is the AI, and then we have built the action in another. It's like you've got a brain which can think, you've got a hand which can actually lift the things, but you've disconnected both of them. So what your brain thinks, your hands can't do, and what your hands do, your brains can't do. So they are kind of disconnected at the minute. Now, and then we wonder why things are not working as we wanted to. So this gap between the knowing and the doing is where most AI projects kind of fail. Imagine a brilliant brain which has nothing to act on. It can only just think. If it can only just think, what is the very point of it? Although Socrates and all might disagree that thinking is all, but still. Now, so when, let's say an AI system, it kind of finds a fraudulent transaction. It found it, but right now it can only mark it and it can only red flag it and say, there is a problem, there is a fraud. But what do you do with that fraud? How do you handle and how do you address and how do you make sure it doesn't happen again in future? All of that handling of that particular fraud, that ticket is raised by a human, it's flagged to a human, and the human then, raises the flag, he sorts it out and he figures it out. So there is always a human in between. Now, we have separated the thinking from the acting, and we call it the architecture. We didn't fail at AI because it wasn't smart enough. We failed because it wasn't allowed to do anything. So we have worked with applications. Now, we are currently living in the era of the APIs. APIs drive everything at the minute. So for the last 30 years, software has been built around this one idea, which is the application. So it's like you click, and then there's a screen, and then you submit it. You click, and there's a screen on it, and then you submit it. So then a human is there who's actually doing the clicking and putting the data in, and he's there in every step of the way. The system waits and the user decides, and then the user kind of coordinates also what needs to happen next and all. The outcomes are kind of manual, even when the system is actually digital. We didn't automate work, we just digitized the interfaces. So rather than doing it certain way, just using UIs, we are giving the user to interface with the system. Now, the silent backbone of our industry, of our revolution, has been the APIs. Now, they didn't make the headlines. Like AI is making so much headline, right? And then when the internet buzz happened, that internet was making so much headline. But APIs, they were very quiet. Nothing, no one talked about it unless you are in the industry. But now everyone's talking about AI. So they didn't have flashy demos as well. And they were very smart, but they were kind of powerless to do their own thing. So AI was actually raised in a lab. We trained the AI like a genius locked in a library with no life systems and no real consequences of his thinking of the data. Now, the AI can suggest next actions, but it cannot call the API at the minute. Now, it cannot retry, and some cannot observe the outcome and react. So it knows what to do, but not how, and then not when. So there was a good thing back there, which was it knows we built a highway, but we still force people to walk. on the highway. So what is so clever about it, right? Nothing. Then naturally, we try to automate things, but we tried to automate the scripts, the workflows, and then the RPAs, and they worked until the reality changes because the reality is the biggest edge case you have available in the system. Now, rules kind of assume stability because, and it's the rules which you program in, saying that this will happen, and after that, this will happen, and then this will follow this. And so basically, we are setting up a rigid system, and there are rules, but in real life, rules are not the norm. Rules are not the norm at all. So if you can't, adapt to those changes, then your system is pretty useless. So you'll have to do something to keep adopting them. Now, APIs evolve and fields kind of change, the exceptions appear. So automation kind of breaks if it cannot adapt. Automation assumes that yesterday looks like tomorrow. Is that any true? It's not true at all. But the reality, it never agrees. No, tomorrow is going to be different, day after is going to be different, everything is going to be different. Now, this is the ceiling. This is the ceiling which we are talking about. Like, there's only so much the AI, what we have right now, can do, but it can do more provided we enable it. Um, then came the Copilot era, where Mukund was talking about how the Copilots are. But again, Copilots, they kind of changed a lot of things. The systems became decoupled and real-time integration became possible, and machines could finally talk to the machines. But what really happened was that, the systems, they kind of suggest, do this thing, send this email. You could probably do this. They were all just suggesting things. They don't finish the job. They just help, they suggest, they assist. They give advice, but they don't own something from starting to the completion. They don't send that email. They need the human to get in between to send that email. They wait for the human to execute. So even now, humans are still the part of the system itself. So here's the reality of the modern work. Too many systems, too many coordination, and too many handoffs as well. So you've got CRMs and you've got the ERPs and the ticketing tools and the custom tools. But who connects them all? It's just the humans. The humans are becoming the glue itself. Now, every modern company has brilliant employees who are doing API orchestration within their box. But then if you see, the HR guy is chasing the finance guy, and then the ops guy is chasing the IT guy, and the support staff are chasing the engineering staff. So it's like this disconnected systems and different humans using different systems. Like the finance guy is probably using the ERPs, which is to manage the internal company's process, and the HR guy is using CRM to get the all sort of leads into the company. So they're all using different softwares, but then it's the human who is having to interact with each other. Now, humans have become the actual integration layer, and that is a terrible use of a human's intelligence. No one kind of wakes up in the morning wanting to be a part of the workflow and wanting to activate something. We want outcomes. We say, we post a job description, we want to be able to work with the new guy who has joined our team. So, but we don't want to be doing, messing with things in the middle. So we are now talking about the shift. Something has to change, and something did change. So we are moving from just clicking apps to actually declaring the intent. So this is the key word here. What is the intent? What are you trying to do here? Don't tell the steps to get the job done, but it's rather that you tell the intent. What is the goal? So in the older world, you'll have a user, and he will say something to the app, and then the app will then talk to other apps, and then it'll get something done, and the result will be there. But in the new world, if you see, you tell the intent to the agent, and the agent will then interact with how many other systems it needs to interact, and what will be there is the outcome which has been set out in the intent. This is not an user experience change. This is an executional model change in itself. So this is where we come, the adaptive agents. An adaptive agent is a system that understands the intent and it observes the live context, what is going on around with the data, what's happening with the data, what are the system parameters and boundaries we are working with, and it reasons intelligently and it acts autonomously across systems through APIs. It's not a chatbot, it's not a script, it's not an assistant, it's an actor. So, um, an adaptive agent again is not just an interface, it is actually an executor. It goes and does what it needs to do to get the outcome what you need. Now, for example, again, a hiring agent, what it will do is it'll observe the pipelines and it'll schedule the interviews, it'll schedule the follow-ups. And again, if there is a no, I mean, there's a no show or the HR person rejected it, then it automatically will go and pick the next eligible candidate and schedule an interview, so on and so forth. No one is going to tell it to do anything. It just knows that there is an unfulfilled vacancy around and I need to fulfill it. So that's the intent it will work along with. Now let's say what makes an agent adaptive. We've heard of different agents and different, generative agent, generative AI and all of that. But what is an adaptive agent? Now, an adaptive agent must have four core capabilities. One, it perceives, it has to listen to data, it has to listen to APIs, to events, to data streams, and it should be able to reason. It uses AI models to decide what to do, and that's where Karthik was mentioning about why are we using LLMs for everything? We could use small language models, and that is a shift we are now taking in our organization, saying that we may not need all of the LLM. We may just get that work done with the SLM. So we're working with people as well for that. And then it acts. It securely executes, the logics across the system, and it adapts. It learns from the outcomes, and then it has a feedback loop within it, which with it learns. So it automatically does all of that. So if it can do all of these things, then it is an adaptive agent. Now, the biggest thing which we have to drill into these adaptive agents is that the real world is an edge case. It's not going to follow this normal flow. There's going to be a lot of differences than the normal flow. Normal flow, anyone can handle it. But if we want an intelligent system, we want it to be able to handle everything which is thrown at it in a proper way, and it can reason its way through that. Now, so for example, in a real world example would be if you perceive that there is a lot of tickets which are coming in, like there's a problem ticket which is coming in. For example, current off aidichu, then everyone's calling, saying that there's no current in my area, there's no current in my. If you're getting many calls like that, immediately an AI agent should be able to see, okay, there's many calls coming of the certain type, and this is a certain severity. It seems to be in this area, so there is a problem in that area. We need to send all our resources to fix it, and we need to switch grids and give the power to that area from somewhere else, and it has to plan and do something. So it has to perceive, it has to get the input, and then it has to reason out saying, why is there a spike? What is the severity of all of these things? And then it needs to act, which is switching and notifying the higher authorities, and then switching into doing what needs to be done so that the power is restored to that area, and learn from this experience on what to do with this. Now, why adaptation matters? Because the world refuses to stay still. APIs evolve, data is incomplete, and exceptions are normal. Karthik was mentioning about, all data can be incomplete, and you still run models with that and all of it. So you need to be always aware that, do we need, is our algorithm or is the way we are implementing our reasoning engine, is it biased towards a certain behaving in a certain way? Sometimes it could be harmful. Sometimes it may not be harmful. So we have to be very cautious about what is allowed and what's not allowed, and the limitations and the boundaries we need to set, so that, we should assume that the model has been trained with incomplete data, with all sets of information, all the edge scenarios defined. So we need to always have guardrails built around it as well. So it should be okay for the adaptive agents to say, I don't know how to handle the situation. Saying I don't know is better than making a call and not letting anyone else know that, this is the reason why I made the call. So we need to be able to find out why a particular call was made. Then adaptation again is not a feature. It is the survival. You need to be able to quickly adapt to whatever change has been thrown at you. Now, adaptation is also how the system will earn trust. So workflows that run themselves. Imagine a workflow doesn't wait for you to come and, guide it what to do. End to end, it does the hiring. End to end, it kind of does the, transformer switching or server switching so that you don't have a downtime. And automatically, if it sees routing failure, then it finds a new route for us for the system to, for the container lorry or whatever, to take a different route and get the product to you, to get the Amazon parcel to you on the time, so that it switches everything, so that you get everything, without anyone saying, oh, there is a block here, there is this here, there is that here, and someone doesn't having to enter saying that this road is closed, that road is closed. But if there is some other system which is, looking at all of that and automatically tells the driver that that is closed, so you take another path. So it perceives, it knows that the parcel needs to reach at this person at this time, and it makes the call, and then it immediately reroutes things. So there's no dashboards with the reds flashing, and there is no chasing, there is no manual stitching. Work that kind of runs itself. No human wakes up wanting to fix all of these problems and having a dashboard where everything is like flashing red. So it'll be nice if the work works itself. So we are left for better things to do, like watching Padayappa on the weekend for the nth time. Right. Now, let's address a concern which everyone has, and that is, autonomous does not mean uncontrolled. Autonomy without control is just pure chaos. And then control without autonomy is nothing but bureaucracy, and we don't want that either. Adaptive agents are policy bound, and they are auditable and observable. So humans always stay in the loop by design. So if we want to take humans out of it, but then where there is needed, we need to be able to get in and see what's happening and reason change. And if the reasoning is right, we should be able to let it go. Or if the reason is wrong, then we'll have to be able to fix it. So there should always be a human in loop sort of a design, which we should think of when we're always designing AI agents. Now, trust here is the real feature. So we should be able to trust our AI system that if something goes wrong, it doesn't understand something, it's being able to notify the humans for us to come in and take a look at it. Now, autonomy also doesn't mean that the agents do whatever they want. And every agent operates inside explicit policies. So what is allowed, what it is allowed to do, and what it is not allowed to do, and under what conditions it must stop and escalate. Policies are not just documents, they are machine enforceable guardrails. So that's what the policy should be. So when we are thinking about it, when we are teaching our young students on, how to become better engineers of future, we need to drill them policy and ethics. They should not be something which is an after fact after you know how to code and build and generate an agent. It should be built in with the whole thing itself. Again, audit trails are very, very important because everything should be logged and traceable and explainable after the fact. And we should be able to say we should not only be able to say what happened, we should be able to say why that happened and what was the data that the AI used to make that thing happen. And again, if you can't see the system, what is running, then you can't believe in it as well. So observability is a very important thing. You need to be able to continuously monitor it and measure its outcome, and it has to be very transparent in behavior. So we shouldn't ask, did it run? We should rather be asking, did it behave as expected? Did it drift? And did it adapt correctly? So all of these things we should be questioning our system when we're designing our system. So the new kind of engineer is not going to be building UI, but rather behavior. And he's not going to be building screens, he's going to be building systems. And then he's not going to be building code, but rather he's going to be building the intent. So you're not building features, but you are making the decision making system. So what should be taught more than the language in colleges and schools is not how to program, but rather how to think, how to build a thinking machine which can think for itself and do something. So how can it make decision? How can I make something make decisions? So that's what you should be helping to learn in schools and colleges. So rather than building screens which you just click click click, you're going to be building decision engines, and you're going to be able to say how to code the intent, what you want your agent to do. So that's what's going to be important now. Now, you should be able to say, what should the system do when the condition changes, rather than what should it do when I click this button in UI. So you need to be able to think in a different way. So the skills that will matter most for future engineers will be APIs and event-driven thinking, how the distributed systems are, and the security, ethics, and responsibility. So you are not just writing code, you are designing the autonomy. Okay, so then what is the new software layer we are going to build? Apps were built for humans, but agents are built for the outcomes. Were built for humans to operate, but agents will be built for the work to complete itself. This is the new computing layer above apps and above APIs. So work itself then becomes autonomous. So let me close with this thing. Every generation of software removes friction. This one removes coordination. The future doesn't click. Let me repeat it. The future is not going to be clicking. It understands the intent, it adapts to the reality, and it executes it. So those who build trustworthy autonomy will define the next era of software. Thank you.